Hi there! We're going to learn how to complete the square in a quadratic expression, and then we'll use that to solve a quadratic equation by completing the square. We'll start with r squared plus 24r plus something. Remember that a quadratic written in standard form is ax squared plus bx plus c. So in this expression, our b term is 24r. To complete the square, we need to take half of our b term and square it, then add that number to our expression. Half of 24 is 12, and 12 squared is 12 times 12, which is 144. So to complete the square, we need to add 144 right here. Now, we have a perfect square trinomial. Let's try another. We have m squared minus 10m plus something, and we need to complete the square. To do that, we take half of our b term and square it. Half of negative 10 is negative 5, and negative 5 times negative 5 is positive 25. So to complete the square, we add 25 here. Do you know what I mean when I say complete the square? Have you seen expressions written like this, m minus 5 squared? That's a square because the term m minus 5 is being squared, or raised to the power of 2. And watch what happens when I expand that out. m minus 5 squared is m minus 5 times m minus 5. When we FOIL this, we multiply the first terms together to get m times m, which is m squared. The outside terms m and negative 5 give us negative 5m. The inside terms, negative 5 and m, give us another negative 5m. And the last terms, negative 5 and negative 5, multiply to give us 25. When we combine the like terms, negative 5m and negative 5m, we get negative 10m. And now look, this is exactly what we had after we completed the square. m minus 5 squared is equivalent to m squared minus 10m plus 25. By completing the square and adding 25 to our expression, we created a quadratic expression that could be written as a square, m minus 5 squared. That's incredibly useful when we solve quadratic equations by completing the square. Let's try that now. We'll solve a squared minus 14a equals negative 13. First, we complete the square using b over 2 squared. Our b is negative 14. Negative 14 over 2 is negative 7, and negative 7 squared is 49. So we add 49 to complete the square. But since we have an equation here instead of an expression, we have to add 49 to both sides of the equation. When I add negative 13 plus 49, I get 36. So we have a squared minus 14a plus 49 equals 36. Now we can rewrite our quadratic expression as a square. We write it as a plus half of the b term squared. Since the b term is negative 14, half of that is negative 7. So we write it as a minus 7 squared. And that equals 36. Now we're ready to solve for a. We have to get rid of the square and the 7 to solve for a. First, we get rid of the square by taking the square root of both sides. Here, they'll cancel out and we'll be left with a minus 7. Here, the square root of 36 is 6 or negative 6, so we'll get two different answers. To finish solving for a, we add 7. 6 plus 7 is 13, so that's one of our answers. And negative 6 plus 7 is 1, so that's the other answer. We solved a squared minus 14a equals negative 13 by completing the square, and we got our two answers of 13 and 1. Let's do one more problem. We have h squared plus 8h minus 9 equals 0. First, we need to get this problem ready to complete the square by adding 9 to both sides. Now we have an empty spot here ready for us to complete the square. We take half of 8, which is 4, and square it, which is 4 times 4, to get 16. To complete the square, we add 16 to both sides. Since 9 plus 16 is 25, our equation is now h squared plus 8h plus 16 equals 25. Now we rewrite our quadratic in its square format of h plus 4 squared, since 4 is half of 8. Now that we have h plus 4 squared equal to 25, we're ready to solve for h. First, we take the square root of both sides. Since the square root of 25 can be 5 or negative 5, we'll get two different answers. Now we subtract 4. 5 minus 4 is 1, so that's one answer, and negative 5 minus 4 is negative 9, so that's the other answer. So h equals 1 and negative 9. Great job solving quadratics by completing the square. Remember to subscribe to my channel for more math videos.